Hi everyone. So this is going to be the fifth video of Apache Zookeeper series, and in this video we are going to see the low-level design of Apache Zookeeper. This video is going to be a little long, so I think you have to watch it with more focus. And before watching this video, I will just recommend all of you to watch my previous videos with any Zookeeper theory videos where you can just learn about the concepts because those concepts are going to be very useful in this particular video. Other than that, first of all, we're going to move on our notepad where we are going to look about the concepts that we are going to code and the features that we are going to make. Now let's get started. So what we are going to do, we are going to design one Zookeeper server. So let's name it as ZK server. And now after that, we are going to design two Zookeeper clients. And we will understand now that why we are going to design two Zookeeper clients. So I have made these three circles. One is Zookeeper server and other are two Zookeeper clients. So we have studied in our previous videos about the Z node. So what we can do with the help of these Zookeeper clients, we can create a Z node in our Zookeeper server. So let me just create one. Suppose Zookeeper client 1 wants to create a Z node dash ABC in this Zookeeper server. So in this Zookeeper server, there will be a node going to be created name dash ABC. After that, what will happen? There will be a TCP connection is already maintained in between them. Now, there should be a concept of a voucher that we have studied in our first video that another clients who are looking for this, like who will register themselves to watch this particular Z node will be notified. So, this Zookeeper client 2 will become our voucher. So, there is a concept of a voucher that we are going to study. We are going to code for it. So what we have seen till now, first Zookeeper client 1 is going to create a Z node in our Zookeeper server. And then we are going to create a pipeline between the Zookeeper client 2 to Zookeeper server where it can register itself to watch that particular ABC node. So this is our voucher. So now whenever this client 1 takes any action on this particular Z node dash ABC, this client 2 is going to be notified. Something like that. Suppose if there's a data in the dash ABC is going to be hello world, and suppose it's going to be changed into hello world savage. So then this client 2 is going to be notified for that. And accordingly, this client 2 can perform some actions in this server. Okay. This is how we are going to code for it. So we see three things, one server, two clients, and about the Z nodes. Now we are going to see the features that we are going to code. So first is going to be that creation of a Z node. The second one is get Z node. So suppose when we are going to get the Z node, we are just going to print them. Okay? Like if you pass the path of that Z node, we are just going to show the data. Third one is going to be delete a Z node. So suppose the client one delete that particular Z node, then the client 2 should be notified if the client 2 is watching that particular Z node. Fourth one is going to be all Z node. It is just going to be a function. We are just traversing a list and just showing all the Z nodes that are present in our code. Then there is a close client. That is an important feature. When the client one goes down, so we'll just create one situation where we are going to close the client. And when we are going to close the client, what will happen at that point? There's epithermal nodes. You know now what is the difference? The epithermal nodes are the nodes. These are the session nodes. When we are going to close the client 1, all the epithermal nodes are going to be deleted. It means the update is going on at that particular node. And if the client 2 is watching that particular node, the client 2 should be notified. Okay. Now we understand the close client. And again, we can restart the client feature. Now there is the seventh point of register Z node with the client. So as I mentioned, we have to register that dash ABCZ node with our client 2. For that registration, we have to create a function so that that particular Z node is going to be registered with our client 2. Moving forward, then there is a function of unregister where we can, like, our work is done, we can unregister that particular Z node. Moving forward, there is a context switching. So we are doing it all in a Java code. So everything is going to work on one client. So if we want to change the client, we are just have to write this function so that we can move to another client. And the last point is going to be that this then exit. We have to close sync function or so that we can close the whole Zookeeper process. Okay. Before moving to the coding part, I just wanted to tell you that you should know some concepts of Java, some concepts of thread pool. So it will be very good for you to understand the coding part of this video. So now let's move to my Visual Studio Code, and now we are going to code from the scratch everything. So now we are on our Visual Studio Code, and I just made one class Zookeeper, and now the first thing that we are going to do to make a class, a static class named Znode, in which we are defining all the parameters that are required to make a Znode. It is going to be static class Znode, and the parameter is going to be string path, string data, and string is ephemeral, and we have to make one constructor for it. So we can make a public constructor Znode that will set the value. So now we have created the constructor of the Znode, and this three data, the only sufficient data that we are required. By default, the node is going to be persistent, but if you, okay, I just did a mistake, you have to make it boolean. So what will happen? If you passed a value true, then it is going to be ephemeral, otherwise by default it is going to be persistent. And one more function that we can make is of toString, and I think our toString function is also completed. And now second thing that we are going to create is our Zookeeper server. So first of all, I have to do static class z Zookeeper server. I also have to make one main function for this Zookeeper class, for our whole Zookeeper class where our code is going to run. So in this Zookeeper main function, what we have to do right now, first of all, we have to make a instance of this Zookeeper server. So let me make it. What I want with my code right now, I want this particular Zookeeper server to run in one separate thread. So that is what we are going to do now. We'll make a runnable interface where we are going to define that this Zookeeper server class should run in a separate thread. We'll go here, we'll do static Zookeeper server thread runnable. It is giving me some error that okay, I'm missing class. We have to, what we have to do? We have to override the run function. So moving forward, there should be one parameter private final Zookeeper server. And whenever this particular Zookeeper server thread class is going to be initialized, so we have to make one constructor, public Zookeeper server thread. And what we are going to pass? We have to pass Zookeeper server, and then we are going to initialize it. This dot Zookeeper server. I wrote it down wrong. Okay, this is fine, and this is looking good to me. Now moving forward, we have to complete this run function as well. So what we are going to do, we are just going to run one while loop, okay, in a true, and we are just going to do one try catch. And what I'm going to do, I'm just going to do thread.sleep for 1000 milliseconds, and let me just pass some exception e and e dot print trace. So what will happen when this run function is going, that particular thread is going to be defined, and when we are going to run this thread, this Zookeeper server is going to start in separate thread. So first of all, let me just write one system.out.println statement as well. So Zookeeper server started. Okay, why did we put this thread.sleep? Suppose there can be an example where the things that are happening on a production, it will take some time. That's why we just put a delay of 1 millisecond where the thread will sleep for a while and the action will be performed. Now let's start this Zookeeper server. For that, what we have to do, we have to just simply go to our code and we have to write thread Zookeeper server thread is equals to new thread. And what we're going to pass, we have already defined here, we have to pass this Zookeeper thread here. And in that Zookeeper thread, we have to pass the Zookeeper server. So what we are going to do, we have to pass new Zookeeper thread, and in that Zookeeper thread, we have to pass the Zookeeper server. So this is how our Zookeeper server thread is ready. And after that, what we have to do, we have to start it. As we start our Zookeeper server thread, that means our Zookeeper Zookeeper server class is going to be run in separate thread and it is up and running. So now we are going to design Zookeeper server class. But I wanted to tell you that before designing Zookeeper server class, that we have to design Zookeeper server and Zookeeper client in parallel. Then only we will able to understand the complete concept. So what we'll do, we'll just copy paste, we'll just write Zookeeper client here. And now we'll design each functions in both of them. So now let's discuss some of the parameters that are going to be in the Zookeeper client. First parameter is going to be our private final Zookeeper server. Second parameter is going to be our private final. Maybe we can just name it at string name. Then it is going to be private final atomic boolean, and we can just name it is running. And that is going to be new atomic boolean, and we can just pass through in it. Okay. Why we just made these all the three parameters? Because first of all is going to be Zookeeper server. Whenever a Zookeeper client is going to be initialized, we have to connect it to a server. So first of all, we have to pass the server in it. There should be a name of that particular client. And the third an important point is that particular client is running or not. So this atomic boolean parameter is going to come in use when we are going to create a function like this. We have to stop that client and we have to restart that client. This particular atomic boolean in is going to come in use at that time. Now let's make the constructor for the Zookeeper client. Now moving forward, what we have to do, we have to create a znode function in this Zookeeper client. So when we are going to make a create znode function, the znode is going to be created in the server. So it will going to look something like that. So what we're going to do, public void create znode. Okay, and then what we'll do, we can just pass a parameter boolean success. Okay, and after the server, there should be a function in the server to create a znode. So first of all, let's create one more similar function in the Zookeeper server as well, create a znode, and what we'll do, we'll pass a boolean here, and what we'll do, we'll say create a znode that will return a boolean, and if it is going to return a true, we'll say that particular znode is created. Other than that, if it is going to return a false, we'll say sorry, we are not able to create a znode. So what we'll do, if success, what we'll say, we are going to pass system dot out dot println, and we'll say that particular client, okay, the client name. Okay, so what we'll do, we'll say this dot name created a znode. And one thing that is missing in that particular znode, that znode is going to be created with some path. Okay, so we have to pass actual a znode. So we have already created this znode class that we are going to pass here. So we'll say znode, and znode is going to be passed in the server as well, and we'll say znode dot path. And that is something that we are going to print. So that is now if it is included in the else situation, what we can do, we'll simply say not able to create a znode. Let's understand it like there is a situation where we cannot create a znode. Suppose if there is a znode already created with the name /abc, so we cannot create one more znode with that name. Now we have to make the same function in the Zookeeper server as well. So when we're going to the create znode function, it will take znode. We are passing the complete znode here. Okay, and the second thing that we are going to pass that we just missed in this function, that we have to pass the client as well. This particular znode is going to be created by which client? So what we'll do, we'll just pass Zookeeper client and Zookeeper client here. And in this function also, we have to change this particular thing. Here we can just pass this. Now what we are going to do, we have to use a set here because it is going to be a single entry with this particular znode. So what we are going to do, we'll just make a private final map string, comma znode, and let's name it as znode map equals to new. Now it's an important point. We are using a map data structure, but with what? Like it is going to be concurrent hash map or it is going to be a normal hash map. So in this situation, we have to use a concurrent hash map. Reason is we are using the concurrent hash map because there are the multiple threads are running and we need some consistency. So for that, you can have to use concurrent hash map. So the function also in the server is going to be synchronous. So what we are going to use synchronize while we are using the create znode function if this z node dot map is going to already contain that key, z node map dot contains that particular key or like container path. So what in that situation, what we'll do? We'll just going to return an error, return false. Other than that, what will happen if z node is not present in our hash map? So what we'll do? We'll just create an entry with in a hash map with parameters with the key name path, and in front of that there is going to be our z node. It will look something like that. Z node dot put. It is going to be z node dot path, and in that it is going to be z node. Okay, now we just did one mistake. Here we have to do zeno dot path. Okay, we are just checking the if the path is exist on that concurrent hash map or not. It is giving me some error. Z node map will come here. Okay, now everything is fine. Okay, and after that we are going to return true. So this is our simple function of creating a Z node. But now let me just make you understand. We have to just keep some more array, some more data, because there are more features that we have to build. So suppose that particular Z node is created and someone is already watching that Z node. So here comes our second feature to notify. So what we'll do whenever there is a node is going to be created, and like take a scenario when someone is already watching that node, looking for that node. Okay, so what we have to do in the create node function also, we have to call the notify watcher. So what we'll do, we'll just make one function notify watcher. So let me just define it. It is again going to be public, synchronized, void, notify watcher. So what is going to take, it will again going to take path of that particular Z node, and after that, there should be a watcher list in our scenario. Then we have to create that particular watcher list that is having the clients. So what we have to do, we have to create one more list, private final. It is also going to be a map of string comma watcher list, and we'll say it as a new hash map. Why we made it a hash map? Because the string is going to be our path, and these Zookeeper clients are all the clients. The list of clients, sorry, I just write it wrong. So this list of Zookeeper clients are the clients that are going to look for that particular path. So what we're going to do now, we'll go forward to our notify watchers, and we will figure it out that this particular path is present in our watcher list or not. If it is going to be present, it will go to that particular list and look and going to send the notifications to that particular clients. So let me just code it. So what we'll do, list of Zookeeper client, we will client list equals to what we have made our Zookeeper. Okay, let me just change the watcher map, and then what we can do, it is the watcher map dot get. We are going to pass the path here, and if that particular path is going to present in our Zookeeper watcher map, so what will it will return that particular list. So now if we get the list, if Zookeeper client list is not equals to null, in that situation we have to traverse the particular list and we have to send the notifications. Or we have to just run the for loop for Zookeeper client list client, and we will just going to pass Zookeeper client list. Zookeeper client will come here, and now there should be a function into our client now where we are going to update, or we are just going to show the message that we got that notification. So it is going to look something like that. We are going to do client dot update. So in that particular update, we can just pass our path. So when we are just going to pass the path, we'll know that but this node is going to get update. Or what else we can do? We can look for this. We can also create one function of get z node that we can call in the client or before client dot update, and then we can directly pass the z node. So let's create one more function, public synchronize get z node. What it is going to take? It is going to take string path, and after that, it is going to look into this particular hash map that this path exists or not. So we just copy this. If this path is going to exist in this z node, what we are going to say, z node with path found, and what we'll do, we'll return z node map dot get path, and this function will return z node. Okay, so we have created one z node function, but what will happen if it is not able to find the path? It will just going to return the znode with this path not found, and it is going to return null. Before that update function, we will call this get znode function. And in this get znode function, we are just going to pass the path. Now we are calling the client's update function, in which we are just going to put one println statement that we got the notification from the Zookeeper server that there is an update in that particular Zookeeper node. Okay, so let's create it. Public void update function, and we will say z node, and if this z node is not equals to null, what we are going to do in this situation, we are just going to say system.out.println, and we are going to say this dot name first of all, because which client is get the notification, and we get the notification for the z node. Which z node? Z node dot path. Now what we have to do, we have created this notify watcher. This function is fine. This function is fine. Okay, so we have to pass the path in this notify watcher. We have to pass the path. Okay, so here it is go something like this, that node dot path. Everything is fine. So before moving forward, there is one more concept we have to focus on one more thing, that these Zookeeper clients can also create epithermal nodes. So we have to also maintain a map where these Zookeeper clients, these Zookeeper clients have created how many epithermal nodes. Then only we will able to delete those epithermal nodes when the clients goes down. Okay, so this is also an important point. So what we are going to do, we are going to maintain one more map, private final map of. This time, what we are going to do, we are going to maintain a Zookeeper client, comma, a list of, or we can say set of, we can just say set of paths, because we are already having a get function, set of string, we can say, where we are going to say client epithermal node map. Okay, that we have created, that is again going to be a new. So what will happen in that situation when suppose we have created this create z node, and if this node is going to be epithermal, so what we'll do, we'll also add that node in this list or in this map. So let me write that down too. If z node dot is epithermal is going to be true, in that situation only what we are going to do, client epithermal node map dot compute if absent zookeeper client, comma, k equals to new, equals to a new hash set. Okay, and in this new hash set, what we are going to do, we are going to say add our path. So, and we also have to maintain one epithermal node list, epithermal node. If the node is going to be epithermal, we're just going to put it into a list as well. We are going to do private final set of string epithermal, and it is going to be epithermal nodes, and we can just say new hash set in our situation. And when it is when any node is going to be epithermal, we are just going to put it in it. So what we'll do, we'll just say epithermal node dot add, and we're just going to say z node dot path. And this is how our create node function is completed. We have also created one create node function in our client, and both the functions are perfectly fine. We have already solved one more problem of get z nodes. So we can always do a get z node from function from the client. So just we have to make one function of get z node in our client, or like so we can simply say public void get z node, and we will just going to pass the path, string path, and this will call the server, this dot server dot get z node, and we're just going to pass the path. Okay, and you will see we have already completed this function. So in our client also we have created this z node functionality, get z node functionality. So our 2 points are completed. Moving forward, what we are going to do, we are going to create a delete z node function. This can be done by client. So first of all, let's create it into the client, and we are going to create that particular delete z node function in our server. Okay, it is going to be very much similar to create z node function. So what will I do? I will just copy paste it and do some changes. We'll just say delete z node. I'm just passing the path here, saying z node. And what we'll do, we'll say delete z node here. And this delete z node function that is going to be created in our server. And we also pass the Zookeeper client that from which Zookeeper client we are going to delete this particular. And after that, okay, we have to just, if it is going to be successful deletion, we will delete it as znode dot, we can simply say path. And if not able to delete it, we'll just return a message that we are not able to delete that particular znode. And in the delete, yeah. Now, what we are going to do, we are going to create a delete znode function in our Zookeeper server. Delete znode function. That is again going to be boolean. And now we are going to pass string path. So for deleting the znode, first of all, that removes that code. Now we have already have so many maps. We have to remove the data from each of them. So let's do it. And after deletion, if any of the client is watching that particular znode, we have to notify that. So if there is a notify watcher, what we have to do? We have to notify that particular watcher. So this is something that is going to happen. So we have to pass the path. Okay. And anyone who is watching that particular znode will get the notification for it. Okay. So let's do it. First of all, for deleting the znode, if znode map dot contains that path, what we are going to say, we are going to say that particular znode is present in that particular path. If it is not, we'll just simply say return true. And now what we are going to do, we will say znode dot remove that particular path. Then if it is going to be a epithermal node, then we have to remove it from that epithermal set that we have created. So what we'll do, we'll just say epithermal nodes dot remove that part. If the znode map dot contains the key path, if it is not going to be found there, then we are just going to say return false because znode is not present. I just typed it wrong. The system dot message is already going to return by the client. Now we have removed all the znodes from all our lists. Now what we are going to do, we are just going to return true in this function. So this is how our delete znode function is also completed. Moving forward to our function of register clients. Okay, so we missed this function actually. We have to make it previously. So what we want right now, whenever we are going to create a client, this client is going to be registered with the server. So there should be a list into our servers as well that this particular clients are active right now. Okay, these particular clients are connected with our servers. So what we are going to do, we are going to create one list in our Zookeeper server saying private final list of zookeeper clients equals to new array list. So we have created that list. Now we have to create one function register client in our Zookeeper server so that our servers knows that these clients are currently connected with our Zookeeper server. So what we are going to do, we are just going to make one function. So public synchronize void register client, and we'll say that then we are going to add this particular client in our Zookeeper client list. So Zookeeper clients dot add Zookeeper clients. Okay, and this particular client will take Zookeeper client. Okay, this is how our function is completed. It is giving me some error. Let me just fix it. Okay, I just made a mistake in my code. I just put one extra s. Now it is fine. So we have completed one more function, register client. Now let's move forward. And now we are going to discuss about the two more functions that are going to be register watch and unregister watch. So that means the client wants to register and wants to look for that particular node to get notified. So in our notify watcher, as you will see, I have told you about this particular function that there is a list of Zookeeper clients right now that are looking for that particular path. Okay. So those particular clients that are present right now, those are the one who will get those notifications. Okay. So now let's create our register and unregister. Now let's create our register and unregister functions in our clients, and then we'll make a register and unregister function in our servers. So first of all, in the client, it's going to be pretty easy. Okay, what we are going to do, we just make public void register watch. Okay, and there is one more function that we are going to make. unregistered watch. We are writing this code in our Zookeeper client. So it is going to return simple. We can just simply say it is going to, it is a void function. So what we can do, we can just do server dot register watch and server dot unregister watch. So what we are going to register with these Zookeeper client, we are just going to pass the path here, string path, string path. What that means, that particular clients want to look for this path. Okay, so it is getting registered for it. So what we'll do, we just pass the path here. We are just going to path here. And now we are going to create this function in our servers, register watch and unregister watch. So let's go there. Okay, now we are in our Zookeeper server and now we are going to create these two functions, register watch and unregister watch. So we missed one thing in our register watch and unregister watch. We have to pass the Zookeeper client as well because this is something that we are required. So when we pass, we just pass the Zookeeper client as well in register and unregister watch, and we have to pass it here as well to pass the client and pass the client here. Okay. Now let's design them. So it is again going to be synchronous function, public synchronized. Okay, we can just make them void register watch, and it will take two things, string path and Zookeeper client, Zookeeper client. Okay, and similarly, we can just make one more function, unregister watch. Now, in these two functions, we know we have already created one watcher here, watcher map that contains string and Zookeeper client. That means for this watcher, we are going to, like, for this particular path, these are the Zookeeper clients that are going to look. We have already created this map, and map we have to do the action. Suppose if we say register, so for that particular string, okay, for that particular z node dash a, we are going to add the clients in that particular list. And for that, suppose if there is a function called unregister, we are going to remove the value from this Zookeeper client list in the watcher map. So let's do it. It's going to be very simple. What we are going to do, watcher map dot compute if absent. Okay, so for this particular path, what we are going to do, we are going to create one entry if it is going to be uh, a null entry here. So we'll just say k dash new array list, and it is going to add a value of Zookeeper client. So we made an entry in it, and now we'll say system.out.println. We can say Zookeeper client dot name is looking for the path. We will simply say path. And this similar thing is going to happen in the unregister. This time, if it is, if this particular path and in front of them this list is going to present, what we are going to do, we are just remove that particular client from that list so that it will not get notified whenever there is a change in that particular node. So let's do it. So first of all, let me just take out that Zookeeper client list. We'll just name it a zoo list. We'll say watchermap.get that particular path. And after getting that path, what we want to do, we will simply, if zoo list not equals to null, in that situation, what we are going to do, we're simply going to zoo list dot remove that particular Zookeeper client. Print else statement where is not looking for that part. And so here we have just completed our register and unregister functions in our clients and server. Now we are going to see about our next functions that are going to be stop client and restart client. First of all, let's make them in our Zookeeper client. So it is going to be again void functions, public void stop client and public void restart client. So let's understand what will happen when we are going to stop the client. The first thing, when we are going to stop the client, the first action that is going to perform in the server is going to be all the epiformal nodes that are present with the help of that client are going to be deleted. That is the first action. And the second action that is going to be happen is that that particular client is cannot watch any actions anymore because that client is down now. So these are the two actions that we have to perform in our Zookeeper server. And when we restart it again, all the properties should come back. So what we will do, first of all, we already made one atomic boolean variable is running. So what we are going to do, we'll simply pass is running dot set new value equals to false. In this, when we are going to restart the client, we will just set it true again. Second action that we are going to perform is server dot remove client from watchers. We're just going to pass this. Okay, so what we are saying right now here, we are saying that if it is going to be like when we are going to stop the client, we'll just remove from all the watchers that this client cannot watch anything anymore. Moving forward, we are going to delete server dot delete all the epi herbal nodes by client. So this is something, this is the second action that we are going to perform. We have to delete all the nodes that are created by this particular client and they are epi herbal. Okay, moving forward, what will happen if we are going to restart the client? If the client is running, we'll just set it true. If it is not running, then only we are just going to set it true. So let me just first put a check if is running.get is not equals to true. In that situation, what we're going to do, we'll set it to true. Okay. And then what we're going to do, we'll just again create a new thread for that particular client and we are going to start that thread. Okay. Thread client thread equals to new thread this. Okay. Client thread dot start. Okay, so now why we are starting the thread, so we have to implement runnable in Zookeeper client as well. So let's do it. Okay. Okay, so now we are going to design our restart client function. So what will happen in the restart client function? Okay, so what we I've just wrote it down that we are just going to set the value true. Okay, but it is little bit much more than that. So what will we going to, if we are going to say is running dot get, okay, and if it is going to come false, okay, we are just going to set it to true. And there is one more thing that we have to do is we have to just create one thread, client thread, okay, new thread, and where we're going to say thread client thread dot start. Okay, so now why we are doing this, because in this particular Zookeeper client, there are multiple Zookeeper clients are also running in some different threads. So we have to make this Zookeeper client also run in some different thread. So we missed this part, but now we are going to do this as well. So what we are going to do again, we are just going to implement runnable. I wrote it wrong, runnable. And what we have to do, we have to create one function, run. And again, the same concept that we have followed in our Zookeeper server, we are going to do the same thing in our Zookeeper client. Okay, so we have made a separate class for the Zookeeper server thread. Okay, so we'll just take it as it is. And now what we're going to do is just copy paste. But there is a tricky part here that we are not going to write this separate out of println. And second thing, we are going to run this thread is running dot get. Okay, when this particular node is active, basically when we are saying that our atomic value of this boolean variable is true, then this thread is going to be asleep for 1 second, because it is showing, we are just taking a real life example that the thread is going to take some time for some actions. Okay, so we have just implemented our Zookeeper client, but the still two functions are missing that are going to be remove client from watcher and delete all the available nodes by client. So we are now going to complete them, and after that I think our almost code is going to be completed. Let's do it. So we are in our Zookeeper server. So we are just going to create these two functions. Okay, first is going to be our remove client from watcher, and another one is going to be delete all the available nodes by the client. Again, these functions are going to be public signalized void. So let me make them this function to be void. After that, what we can do is remove client from the watcher function. Now we're going to travel this particular list, Zookeeper client watcher list. Okay, now we're going to travel this particular list of Zookeeper client in our watcher map. Okay, watcher map dot, and we are going to value water map dot values. Okay, so what we are doing in our watcher map, we already know in the front of the path, there are the list of the zookeepers. So we are traversing that list, and now what we are going to do in every list, we are going to remove our client so that it cannot watch any path now. Okay, so what we're going to do simply, we are just going to say watcher map dot. Oh, okay, we can simply say watcher list now, and we're going to say watcher list. Are we doing anything wrong here? Okay, there's a spelling mistake. Okay, so we are just going to say watcher just dot remove our particular what we are going to remove our Zookeeper client. So let me spell Zookeeper client, and we are going to remove our Zookeeper client from this particular list. Let me just do it, and I think it is done. We removed all the clients that are watching that particular node. As the node will go down, we will remove them from the watcher list. Okay, moving forward. So now we have to delete all the ephemeral nodes for the client. So what we have to do, this is pretty simple. What we are going to do, we have already created one map here where we are storing the data in front of client ephemeral nodes, where in the front of the Zookeeper client, there is a string of ephemeral nodes. So what we are going to do, we simply say dot get our Zookeeper client. Okay, so we'll get set of string so that contains some paths. Now what we're going to do, we'll just traverse that path and let's name it as path list. And now what we are going to do, we're just going to delete all these paths. Okay, so we'll just simply call delete z node function. We've already created it. Okay, we'll just call it. And after deletion of all these z nodes, what we're going to do, we'll just remove this particular pa- Zookeeper client from client ephemeral nodes as well. So what we're going to do, we're just going to say client ephemeral node map dot remove Zookeeper client. After that, we can just simply do some system.out.println. You can just put it here. Okay, this dot name. Okay, what we can say path. Okay, let me just put it registered to watch. Okay, and now we are going to say here unregistered to watch. In the stop client as well, we are simply going to say client is stopped, and for it, we are going to say client is restarted. And now it is still showing me some error. Let me just fix some else and let's see. Yeah. So there was an error that I was missing one bracket and I fixed it. Now everything is fine. So let me just recall you everything what we have done till now. We have created a Zookeeper server, all these maps where we're just storing the value. We have created the function of register client, create Z node, notify the watchers, get Z node, notify watchers, delete Z node, register a watch, unregister a watch, remove client from the watcher, delete all the ephemeral nodes from the client. So these are the functions that we have created in the servers. The functions that we have created in the clients are our create Z node, update Z node, get Z node, delete Z node, register a watch, unregister a watch, stop the client and restart the client. So I think our coding part is almost completed. Now what we are going to do, we are going to make a mains function that I'm going to skip for now. I'm just copy paste some code that I've already written, and then we are going to run this whole part. Okay, and we'll see that what we are getting and it is working or not. So now I have copy pasted the main function. So I usually get like 1-2 errors in it. So let me just tell you the errors. So first of all, in our Zookeeper client, if you are seeing this code, we have just passed the atomic reference here. So what I've done is in our constructor, you have to just remove. It was written like atomic boolean, so you have to just remove it from here, and now it is perfectly fine. And the second error that we are seeing is server dot list all the nodes. Okay, so we just forgotted one function. Okay, so what we can do is we can just go to Zookeeper server and we can just make one function public void just all the nodes. So what we are going to do, we are just going to traverse all the values of the z node map, and this is how we are just going to print all the values and just showcase all the values in our console. Okay, so what we can do, if z node dot z node map dot is empty. That will say no node is present. Secondly, what we can do, if it is like present, then we can just simply run a for loop on the whole values of this particular z-node map. So what we can do, map dot entry, and then we are going to pass string comma z-node, and we can say entry set entry, and we'll say z-node map dot entry set, and for that we are just going to system dot out dot println. Okay, and what we are going to do, we're just going to print entry dot get values. Okay, get values dot path will be fine. So now what we are doing, we are just simply printing all the z-node maps. Okay, so this is our fourth one that was missing in our code, and now I think we are good to go to run the whole program. So this main function, let me just explain you also. So what we are doing here, we have just created a Zookeeper server. After that is a scanner line where we are just taking the inputs here. That is going to help in taking the inputs here. After that, we have just created one thread by which our server thread is running, that we have created in our starting. That is our Zookeeper server thread that we have run here. That is our one thread. That is our first thread. After that, there is our clients that I've created. And I already told you that we are just getting one error here. So I've just fixed it. Okay, this is our second thread. This is our third thread. Okay, so I've also started these threads. Now it is an important point that solves our 9 switch context problem. Okay, so when you will see that I've just selected the client one, okay, and we are just going to perform all the actions with the help of the client one right now. But whenever we are going to switch to the ninth pointer, we can switch the client to client two. So what we are doing is we are just switching the client. Okay, anything else is, there is nothing else in this code. We are just taking the normal inputs for the Z nodes, we are seeing the client, we are just watching and everything. So I was able to find out two more errors in the code. That is, first of all, when we are deleting the Z node, what we just put the notify watcher here. Okay, but we already removed it from the path. So first of all, we have to fix it. We have to move it to this. First of all, we have to notify, and then we have to delete it from the Z node map. And there is one more error. When we are deleting the ephemeral node by the clients. Okay. Then also what we can do is we can also notify to the client that are watching. So when we're deleting the duplicate, when that Zookeeper client is getting down, we have this path place. So what we can do in this pathway, we can just traverse it for what we will say string. What I'm doing, string path list, and again we can call the notify watcher for this path, and after that we can perform our action of delete those z node. Okay, we can simply do this. Okay, now it is good. Now we are notifying them when particular z nodes are getting deleted, but we are still notifying to the other clients. We all the different nodes of the client, yeah, notify watcher to the path. Perfect. Now we are good to go, and now we are going to run our code in our terminal, and let's see what we are getting. So let me do it. I already ran it one time. That's why I got those errors. I just removed that part from the video, and now we are going to run this. Okay, so this is how it looks. Okay, our Zookeeper is up and running. Now what we are going to do? First of all, let's create one Z node. So under your choice, I say one. We are going to say like Z node path is going to be like slash ABC. The data is going to be, let's say, hello zoo, and it is going to be Abhihama. Make it. Let's not make it Abhihama. Okay, we'll just pass the fonts. Client created Z node slash ABC is created. Let's see. our all the nodes. We have just created this function, force function. Now we can see that ABC is visible. Let's see our third function, get the node is visible or not. So what we'll do, if we see it's ABC, yes, the node with this path found. Now we do a delete function. You will say enter the Z node with the path to delete. We are going to delete the ABC, and now we are going to do the fourth one, view all Z nodes. See, no node is present now. Okay, so our all the four functions are working fine. Okay, now we have to test 5, 6, 7, 8, and 9. Okay, for that, what we are going to do, we are just going to create again the Z nodes. Okay, so let's do it. We'll again press 1, enter the Z node path. Let's create ABC. Okay, Z node data is going to be hello. Okay, is it going to be epithermal? Yes, let's create it epithermal. Now, what we are going to do is, again, let's make it one more node for you. That is going to be slash PQR. Okay, I just did a mistake. Okay, now it is not going to run. Okay, let's do it one more time. Let us see. Okay, so we have to test all these 5 points. All the other points are tested. Okay, so now what we are going to do? Again, we are going to choose our first. We have to create a Z node. So let's make it ABC. Z node data is going to be anything random. If we have my true, again, what we are going to do? We are going to create one more Z node slash PQR. Data can be anything. Okay, if we have null false. Okay, now we are going to test. So here, see, we have the two nodes slash ABC and slash PQR. Now what we can do is we have to stop the client. And when we are going to stop the client, okay, so what will happen? This ABC node should be deleted, that is epithermal, but slash PQR node should stay into our system because it is persistent node. Let's see if it is working or not. So what we have to do, we have to just press try, enter your choice. And this is also my first time that I'm testing this code. Okay, so client 1 is stopped and all the epithermal nodes that are related to this client should be deleted. So now we are going to again get the Z node. And okay, so we did it wrong. Okay, Z path found, but now let's do 4 and see. ABC is deleted. We just got slash PQR because it is a persistent node. Okay, moving forward, now we are going to test the sixth one, restart the client. Okay, so what we are going to do, we're just going to press 6. Client 1 is restarted. Now, what we are going to do, restrict client to both as the node. So first of all, client 1 has created the node slash PQR, but now what we have to do, we want client 2 to watch it. So we would first of all do the context switching to the 9 pointer that we have created to switch the context. Now you can see we are with the client 2. So after that, when we are with the client 2, what we are going to do, we'll just register it for watching. So we'll just say 7 point and we will say slash PQR. We are saying that client 2 is going to look for the slash PQR. Now we are again going to switch the context. And now what we're going to do, this is the important point right now. What we are going to do, we are going to press the 2. So we are going to delete that slash PQR and now we are going to see that client 2 is getting the notification or not for deleting this particular slash PQR Z node. Okay, so now we are going to delete it as well. Okay. Client 2 we get the notification for slash PQR. So we have sent the notification to client 2 as well, and we also deleted this particular Z node. If we are going to do slash 4, see it is giving no notice for that. So hence we have tested all the cases here. So now we just saw the complete LLD of the Zookeeper. So it's now the time to wrap up the complete video. Thank you so much for watching me. This is my first time shooting this type of a coding video and it was very tough for me. So next time when we are going to meet, we are going to see the system designs problem that Zookeeper can solve. So and thank you so much for watching me. Bye bye.